Sport on this edition of Encyclopedia Galactica. How the stars, planets and moon move across the firmament, and how to get the best from your binoculars. A detailed look at the night sky with the stars and constellations of the northern summer and the southern winter. Cygnus in the north and Centaurus in the south. All in Encyclopedia Galactica. This is a real picture of our planet rotating in space. Neither artist's impression nor computer graphic, but time-lapse from a space probe. It's this spin of the Earth, never before recorded from space, that causes the sun to trek daily across the sky. A 24-hour cycle that makes day and night, sunrise and sunset. What many don't realize is that this same spin moves the stars through the sky. A combination of the rotation of Earth and its annual orbit of the sun means that our perspective of the cosmos through the sun changes by 4 minutes every day. This line is a partial view of the sun's seasonal movement against the background stars, the ecliptic. Astrologers of old placed figures along the line, forms suggested by groups of stars, groups we know today as constellations. The constellations of the ecliptic formed the zodiac, a pattern found even in the temples of ancient Egypt. Astrology and astronomy have long diverged, but the mythical names of the constellations persist. To find their way about the heavens, modern astronomers divide the sky into a grid. Longitudinal lines are called right ascension, calibrations of hours, minutes and seconds. Latitude or declination marks degrees north or south of the celestial equator. The index finger and little finger are the simplest measuring device. At arm's length from the eye, they measure off roughly 15 degrees against the sky. That's equivalent to 30 moon breadths, for the moon, not to scale here, fills about half a degree. The clenched fist equals some 10 degrees. 3 fingers, 5 degrees. 1 finger, approximately 1 degree, or 2 moon breadths. This deliberately defocused photograph reveals the true colors of stars. We see them like this, because our eyes are insensitive to the subtleties of starlight. The stars should look like this, an astronomical photograph, or the view through binoculars. Good binoculars are the first essential for a new observer. Marked on every pair are numbers specifying magnification and lens size, these 10 times 50. The 10 indicates that this pair will give a 10-fold magnification of the image. The 50 is the size of the lenses, both 50 millimeters. Here, the eyepieces are marked 5 millimeters. That's the width of the exit pupil, the light beam from the eyepieces. The size you need depends on age. If you're under 40, the pupils of your eyes will dilate to 7 millimeters. If you're over 40, just 5. So, if you're young, you'll see the best images through an exit pupil of 7 millimeters. Therefore, look for binoculars marked 7 times 50, or 10 times 70. By dividing the figures, you get the exit pupil. What we see in binoculars depends on where we are on Earth. The axis of Earth has the North Pole pointing close to the pole star Polaris. Thus Polaris is the only virtually fixed star in the sky. From wherever you stand on Earth, only half the sky is visible. That's why Polaris appears lower and lower in the sky, the further south you go. By the time you reach the equator, Polaris will be sitting on the horizon from, say, Nairobi. In the southern hemisphere, Polaris disappears altogether. But starting from Singapore, the south pole of the sky gets higher and higher the further south you travel. Here, with the Anglo-Australian telescope in silhouette, the stars of the southern polar region, as Earth rotates. This is a chart of the region. The Milky Way stretches across the sky, an edge-on view of our galaxy. Top center is Crux, the stars of the Southern Cross, a signpost. Extend a line through two of them, and there's the southern pole, an empty space. Within the circle are the circumpolar stars, visible any clear night. Among them, the large Magellanic Cloud and its companion, the small Magellanic Cloud, satellite galaxies of the Milky Way. Top left to Alpha Centauri. This is the brightest member of the constellation, the group of stars known as Centaurus. To the right, and Canopus, the second brightest star in the sky. It belongs to the constellation of Carina. Downwards now to Hydrus, the constellation of the Little Snake, and below to Achernar, the most brilliant star in the long and winding constellation of the river Eridanus. To the left, Pavo, the Peacock. Just above, Ara, the Altar. A little to the right, Triangulum Australe, the southern triangle, and nearest the southern pole, Octans. And there they are, the trails of the polar stars in an overnight exposure. To the northern pole now, in the second leg of this introduction to the heavens. The Milky Way is strung across the northern sky. The pole star Polaris is at the very center, shining bright in the constellation of the Little Bear, Ursa Minor. Next door, Draco, the constellation of the Dragon. Just below, Ursa Major, the Great Bear. Top center, Cassiopeia, the Queen. To the left, Hercules, another Greek hero. Next to his queen, Cepheus. And top right, the constellation of Perseus. Some bright stars, Vega in the constellation of Lyra. Higher up, Deneb in Cygnus the Swan. And to the right, Capella in Auriga. And now those northern stars in another long exposure. The best guide to the northern polar sky is the constellation of Ursa Major. From these two stars is the direction of the pole star Polaris. Polaris in Ursa Minor. A line through Polaris from Mizar in Ursa Major leads to Cassiopeia. These two in Ursa Major point to the star Capella, a brilliant point in the constellation of Auriga. This pair in Ursa Major point to another important star, Regulus. Regulus in the constellation of Leo. Finally, extend the tail of Ursa Major, and it leads to Arcturus, a red giant star in the constellation of Boötes the herdsman. Go on a little, and there's brilliant Spica. An introduction to the workings of the sky. Stay with us after the break, when we begin our detailed look at the stars and constellations of the summer sky in the northern hemisphere, and go south for the stellar winter.
Be a two-car family with a 16-valve Nissan Primera.
Discovery always brings you the finest documentary programs from around the world. And now we introduce our own teletext service designed to provide Discovery program information and interesting features. Available in 5 languages throughout Europe to viewers with teletext televisions. As a special introduction to Discovery Text, we're offering a luxury cruise with Discovery Cruises to the winner of our competition. The questions are in our new teletext pages. See page 100 for details. Discovery Text.
On the Learning Channel, Adult Learners Week. Programs to encourage you to return to learning or inspire you to take up a new hobby. Programs on literature, information on green issues, and practical advice for those returning to the workplace. Whether you're a busy working mother or happily retired, there's bound to be something just for you during Adult Learners Week, all this week on the Learning Channel.
He says the universe is a strange and wonderful place. He says reality will always outrun imagination. He says there will always be things unknown and perhaps unknowable. Tonight at 7:30, you too can enter Arthur C. Clarke's world of strange powers on the Discovery Channel.
The glory of the Milky Way, our edge-on perspective of the galaxy in which we live. An astronomical vista best observed when it's summer in the northern hemisphere and winter in the south. A time when the most powerful telescopes on Earth can peer into clouds of gas and dust. When they can glimpse the galactic center, and who knows, a black hole. Time for the stars of Alpha Centauri, little more than 4 light-years away. The season of the Milky Way. They look fixed to us, but most stars are in motion around the galactic center, although in a human lifetime they won't appear to move at all. The 200 billion stars of the Milky Way, all gently turning. One of them, our Sun, takes 200 million years to orbit the galactic center. If we could fast forward 10,000 years, the stars would reposition like this. As it is, it's the point in Earth's orbit of the Sun which determines our view of the sky. Right now, it's summer in the northern hemisphere, and towards the pole, the sun may barely set. But in the mid-latitudes, this is the sky, the Milky Way stretching overhead. We're in the north, looking north. These are the constellations of summer. Towards the horizon, the bright yellow star, Capella. Above, in the Milky Way, within the W-shaped constellation of Cassiopeia, the debris of a star that exploded 300 years ago. Cassiopeia A massive radio source, but no good optically. The circle in the inset is our Sun. Imagine traveling away towards our nearest stellar neighbor. This is the position our star would assume in the cosmos, an insignificant dot before the W of Cassiopeia. Top right in the Milky Way in Cepheus, the pulsing star Delta Cephei. It's a so-called Cepheid variable. Such pulsing has enabled astronomers to calculate the distance of Cepheids, and therefore to measure the universe. We're now looking south, the Milky Way again, and on the far right, Corona Borealis, the northern crown. Next door, mighty Hercules. And top center, Lyra, the constellation of the Harp. In the Milky Way, Cygnus, the swan. Below, to tiny Delphinus, the dolphin. Again in the Milky Way, Sagitta, the arrow. And beneath, Aquila, the eagle. Bottom left to Capricornus, the sea goat, and at the other side of the Milky Way, Ophiuchus, the snake holder. To the right, Serpens, the snake itself. And lastly, at the bottom, Sagittarius the archer, with a hint to the right of Scorpius. The first close-up is top right in Hercules. Here is M13, a globular cluster of 100,000 stars, good through binoculars. In Lyra top center, the star Vega. Brilliant Vega has a ring of dust, possibly a planetary system in the making. Lower in Lyra is the double star Chelyabinsk. They can't be separated in a small telescope, but they seem to stream off a trail and be so close they exchange material. Next to them in Lyra, M57, the famous Ring Nebula, a puff left over from a star that exploded hundreds of thousands of years ago. Excellent in a small telescope. And the debris of another ancient explosion, the Cygnus Loop, not so easy to spot. But through the Hubble Space Telescope, a shock wave still racing through space. Here's its position in Cygnus. Lower in the Milky Way to Sagitta, and a cosmic showpiece, M27, the Dumbbell Nebula. It's the shroud of a slowly dying star, and good in binoculars. Still lower to Aquila, and the bright star Altair, just 16 light-years away. Altair spins so fast, it has bulged into an ellipsoid. Still in the northern hemisphere, these are the summer constellations from further south, from the Mediterranean or Florida. Sagittarius is now well clear of the horizon, and beneath is Corona Australis, the southern crown. On the right, the whole of Scorpius. Up here, M16, a cluster of stars immersed in the Eagle Nebula. fine in binoculars, they formed 2 million years ago from the gas and dust which still surround them. This central region of the Milky Way abounds in splendor. We're scanning the vicinity of Antares in Scorpius, a vast nebula, a cloud of dust and gas 5 light-years across. Thousands upon thousands of stars. The galactic center, in this case a picture from Australia. The true center, however, is obscured by cosmic fog, but there is a view by radio telescope. This radio image suggests a cloud pattern caused by a black hole, a place where whole stars are devoured. But this infrared picture upsets the theory. It shows gigantic stars unperturbed at the galactic center. The region remains a mystery. As Earth's seasonal tilt has given us summer in the northern hemisphere, so it's winter in the south. With the Milky Way arching overhead, this is the southern sky. The winter constellations from the southern hemisphere looking north. In fact, the inverse of the sky from the north. Shining brightest in the south, Alpha Centauri, a triple system, of which this red dwarf is the closest star to Earth, Proxima, just 4.3 light-years away. Here's the position of Alpha Centauri in the Milky Way. And these are the surrounding constellations. Alpha Centauri is in Centaurus. We're now looking south in the southern hemisphere. Top right in Centaurus, a globular cluster. This one is the finest example in the heavens, Omega Centauri, 1 million stars bunched together in a spherical cloud. Several of these clusters sit like satellites over the center of the Milky Way. Again in Centaurus, one of the loudest radio sources and visible in binoculars, the phenomenon of Centaurus A, neither star nor cluster nor a single galaxy. In fact, 2 galaxies in one, a galactic collision. Next time in Encyclopedia Galactica, we take another look at the night sky. We'll see Andromeda in the northern autumn sky and the clouds of Magellan in the southern spring, and direct the telescope towards the familiar pattern of Orion, visible in both the northern and southern skies. Next time in Encyclopedia Galactica.